Professor Diaz here, and in this video I'm going to further demonstrate how to calculate opportunity cost and thus absolute and comparative advantage. So here I have a homework problem. Vincent and Jean are two cooks who work in a village. Each of them can either bake cakes or make pizzas. Okay, so again, this is a model. We have two people rather than two countries, and they can do one good or the other, cakes or pizzas. That's all they can do. Every ingredient is readily available to them, and the only scarce resource is the cook's time. Okay, so opportunity cost here, trade-off, cakes or pizza. Vincent can bake 10 cakes or make 5 pizzas in an hour. Jean can bake 12 cakes or make 8 pizzas in an hour. Please answer the 4 questions. Now, the big assumption here too is that this is a linear opportunity cost because it makes the math easier. All right, so we're not looking at a curved opportunity cost, a curved production possibilities frontier. We're just looking at a straight linear opportunity cost. Okay, so I went ahead and taken this information and created it in a graph already. The question is going to ask here, which has the absolute advantage in cakes, absolute advantage in pizzas, comparative advantage in cake, and comparative advantage in pizza. So I've put all this information into a couple of graphs here. And we can see Vincent and Jean, and we can see cakes on the y-axis and pizza on the x-axis. Again, remember this is y, and then this is x, okay? So we've got cakes and pizza, and you can see the problem says that, let's see, Vincent can bake 10 cakes or 5 pizzas. So I have here 10 cakes or 5 pizzas, 5 right there between 4 and 6, and that creates the production possibilities frontier. And Jean can produce 12 cakes or 8 pizzas. And so there's the PPF, productions possibility frontier, for Jean. Now we need to do the calculations. Well, I guess before we do the calculations, we can answer 1 and 2 pretty easily. Who has the absolute advantage? Okay, well, who can produce the most cakes? Jean or Vincent? Well, of course, Jean can do 12. Vincent can do 10. So Jean has the absolute advantage in cakes. How about pizza? 8 and 5. Jean has the absolute advantage in pizza. This isn't always the case. If you have the absolute advantage in one, you won't necessarily have the absolute advantage in both. But in this case, that is what's happening, right? It could have been something like this, right? Where, Jean could only produce 4, but 12 of this. And so in that case, Vincent would have had the absolute advantage at 5. But Jean has absolute advantage in both. Now, comparative advantage is the one that's a little bit more tricky to figure out. So first it asks us which cook has the comparative advantage in baking cakes. Okay, so we want to figure out the cost of producing a cake in terms of pizza. So how much pizza do we have to give up per one cake? Okay, so we want to know pizza per one cake. So I'm going to say I want to know Vincent's pizza per one cake, and I want to know Jean's pizza per one cake. Okay, I basically want to know if we're trying to calculate the comparative advantage for baking cakes. I want to know how much pizza is it going to cost me to produce one cake. All right, so that's what we're trying to figure out. Now the P per C is going to be the divided by, and this is where I think it makes it easy, right? So for Vincent, we have 5 divided by 10, right? Which pretty easy math here. 5 divided by 10 equals 0.5, 1/2 pizzas per cake. And Jean has 8 divided by 12. 8 divided by 12. And that equals 0.67 pizzas per cake. Now, how do we interpret this data? Who has the lower opportunity cost? Well, the answer is that Vincent has the lower opportunity cost because Vincent only has to give up 0.5 of a pizza to produce 1 cake. Gene has to give up 0.67 of a pizza to produce 1 cake. So what this is effectively saying is that to move over 1 pizza, right? How far down does this have to come? Well, it has to come down half for Vincent, but it has to come down 0.67 for Gene. Okay, so we would say that Vincent has the comparative advantage in producing cake. Okay, so we can check the solution here, and there, in fact, Vincent is the correct answer. Going back then and calculating the other way, who has, okay, we're going to calculate which cook has the comparative advantage in making pizzas, right? Pizzas. So now we're going to say, how many cakes can we produce for the cost of 1 pizza, right? So we want to know the cost of producing a cake. How much pizza will go down? Okay. So in this case, let's just go ahead and make some notes. Switch the color, make it a little bit easier. Vincent, we want to know how many cakes is it going to cost per 1 pizza. Okay. And for Gene, we want to know how many cakes it's going to cost per 1 pizza. Okay. So KP, cakes per pizza, for Vincent is 10 divided by 5. Again, pretty simple math there. 10 divided by 5 equals 2 cakes per pizza. So again, what does this mean? If we want to go up 1 pizza, we're going to have to go down 2 cakes. Okay. So then for Gene, cakes per pizza, we've got 12 divided by 8. 12 divided by 8 equals 1.5 cakes per pizza. So who has the comparative advantage in producing cakes? In this case, the answer is Gene, because Gene, they both want to go up in 1 pizza, right? Here's a pizza, here's a pizza. Both of these people say, hey, I want to plus 1 pizza, plus 1 pizza. How much is this going to cost? And here we're saying, okay, well, cakes per pizza, it costs Vincent 2 cakes per pizza. It costs Gene 1.5 cakes per pizza. So who can do it more efficiently? Well, obviously the answer is Gene. That means the Gene has the comparative advantage in the production of cakes. In the production of pizzas. So again here, for which cook has a comparative advantage in making pizza? Our answer, Gene. And we'll check. And that is in fact correct. So I do know this can be confusing. It's not uncommon for students to struggle with this a little bit. And the only way to get around that is to practice and really think it through, right? It definitely helps to draw these graphs and think it through. You may not have time to draw graphs on the exam. Depends on how fast you go on other questions. But you don't need to, right? We could have done all this math without having the graphs. The graphs just help us visually see what's going on. So hopefully this helps. And as you have more questions, please let me know.